the universe has always been a source of fascination, inspiring awe and wonder among those who look up at the stars and contemplate the vastness of the cosmos. The idea that everything around us, from the very planet we live on to the farthest reaches of space, came into existence through an intricate set of natural processes is a concept that has evolved over centuries. Yet, despite our best efforts to understand the universe, it continues to present us with questions that seem to defy even our most advanced scientific theories. Over the last few decades, the realm of cosmology has experienced groundbreaking shifts that have challenged the foundations of what we thought we knew. The introduction of the James Webb Space Telescope, one of the most advanced pieces of technology ever built for space exploration, has intensified this revolution, providing unprecedented insights into the farthest corners of space. Some have boldly argued that the universe is a product of its own creation, suggesting that it somehow created itself. This claim seems to defy logic at first glance, as it appears to violate one of the most fundamental principles of reasoning, the law of contradiction. This law, a cornerstone of logic, asserts that something cannot be both itself and the cause of its own creation at the same time. For those who subscribe to a rational, logical worldview, this presents an undeniable paradox. Yet, the question still lingers: is it possible that the universe has indeed created itself? Or is our understanding of how the cosmos works fundamentally flawed? The brilliant mind of Charles Colson was firmly rooted in the belief that the universe is governed by logic and rationality. He argued that everything in the cosmos, from the formation of galaxies to the behavior of the smallest particles, could be explained through reason, logic, and the application of the scientific method. Colson's ideas were grounded in a worldview that demanded proof through facts and figures, physical, measurable, and observable phenomena. He maintained that, in such a universe, there was no room for the notion of self-creation, and that anything that exists must have a cause that precedes it in time. However, as we delve deeper into the discoveries made by the James Webb Space Telescope, the lines between logic and mystery begin to blur. We are witnessing a revolution in cosmology, one that forces us to reconsider long-held assumptions about the nature of the universe, its origins, and the laws that govern it. The insights provided by the JWST, which allows us to peer further into the cosmos than ever before, have revealed phenomena that challenge the very core of our previous understanding. In 2022, the scientific community was buzzing with anticipation as the James Webb Space Telescope, a state-of-the-art observatory designed to peer into the deepest corners of space, began to transmit its first images back to Earth. These images were nothing short of spectacular. The clarity, detail, and resolution of the pictures taken by the JWST exceeded anything ever seen before. But while scientists and space enthusiasts marveled at the beauty and complexity of these images, they soon realized that the telescope was revealing something far more profound, something that could potentially upend the entire field of cosmology. One of the most startling discoveries made by the JWST was the identification of galaxies that appeared to be far older and more developed than previously thought. According to the standard model of cosmology, galaxies were believed to have formed gradually over billions of years, starting with simple, small structures that eventually coalesced into larger, more complex galaxies through processes like mergers and accretion. This theory fit well with the established timeline of cosmic evolution, where the first galaxies were expected to form about 1 to 2 billion years after the Big Bang. However, the galaxies observed by the JWST were different. Some of these galaxies, detected in the earliest epochs of the universe, appeared to be already highly evolved and far more complex than should have been possible so early in cosmic history. The images from the JWST revealed galaxies that existed just 200 to 300 million years after the Big Bang, a mere fraction of the time that traditional cosmological models predicted it would take for galaxies to form. This discovery sent shockwaves through the scientific community, forcing astronomers and physicists to confront a paradox: how could these early, complex galaxies have existed so soon after the Big Bang? According to the standard cosmological model, the universe should have been a dark, almost featureless expanse for hundreds of millions of years after the Big Bang, with only the faintest traces of matter slowly beginning to coalesce into stars and galaxies. Yet the JWST had found evidence of galaxies that were not only present in this early era but were shining brightly and exhibiting advanced structures. The implications of this discovery were profound. If galaxies were able to form so quickly and develop so early, it called into question the entire timeline of the universe's evolution. Were the assumptions that formed the basis of our understanding of cosmology, such as the slow, steady evolution of the universe after the Big Bang, incorrect? Was the universe capable of producing highly developed galaxies in a much shorter time frame than previously thought? To answer these questions, scientists began to explore new models of galaxy formation. One such model, known as the Starburst theory, proposed that the early universe may have experienced violent, rapid bursts of star formation that accelerated the creation of galaxies in ways that had not been fully appreciated before. The Starburst model suggested that, instead of the slow, steady accumulation of matter that was once thought to have occurred, the young universe may have gone through explosive periods of star formation, during which massive clouds of gas and dust condensed under intense gravitational forces to form stars at an incredibly rapid pace. The Starburst model provided a new framework for understanding the formation of early galaxies, and the data from the JWST seemed to support this theory. The galaxies observed by the telescope were much brighter and more massive than they should have been for their age, which indicated that they had undergone rapid bursts of star formation. In these periods of intense activity, stars were born at a rate far greater than the gradual processes that had been previously assumed. These explosive periods of star formation could have created enough light to illuminate the early universe much faster than traditional models predicted. But how did this phenomenon occur? What could have triggered such bursts of star formation in the early universe? The answer, according to new simulations based on JWST data, may lie in previously unknown gravitational interactions and the influence of dense gas clouds. These processes may have caused the rapid collapse of gas and dust, triggering the formation of stars at an unprecedented rate. These violent, irregular events created the conditions for the rapid evolution of galaxies, filling the early universe with light and matter far sooner than had been imagined. The new models were not without their critics, however. While the idea of rapid star formation through bursts was intriguing, it still left many unanswered questions. For one, the models assumed that star formation in the early universe was not a steady, linear process but rather a chaotic, episodic event. This contradicted the older, more familiar picture of a gradually evolving cosmos, where galaxies and stars slowly came together over vast spans of time. Could it really be true that the early universe was a much more dynamic, turbulent place than we had previously thought? Moreover, the models also had to reconcile the new data with the overall structure of the universe. The standard cosmological model posits that the universe must be largely homogeneous on large scales, meaning that its basic structures, galaxies, clusters of galaxies, and the cosmic web, should be distributed evenly throughout space. However, the Starburst model proposed that intense bursts of star formation would be localized events, clustered in certain regions of the early universe. How could such localized phenomena fit into a larger, more uniform cosmic structure? These questions were not easily answered, but the discoveries made by the JWST had already forced scientists to revise their understanding of the universe. The telescope's observations of galaxies and clusters of galaxies that existed far earlier than expected, and which were much more developed than anticipated, had cast doubt on long-standing theories of cosmic evolution. It was becoming increasingly clear that the universe was not unfolding according to the simple, gradual processes that had once been assumed. One of the most perplexing discoveries made by the JWST was the observation of massive galaxy clusters that appeared to have collided and merged far earlier than the standard model predicted. According to traditional cosmology, galaxies should have taken billions of years to merge and form the enormous clusters that we see in the present day. However, the JWST showed us that these massive clusters, some of which existed as early as 6 to 7 billion years after the Big Bang, were already in the process of merging long before they should have. This created yet another puzzle for scientists to solve. How could such massive objects have collided so early in the universe's history? The implications of this discovery were profound, as it challenged the very idea that galaxies form slowly and merge gradually over time. If massive galaxy clusters like El Gordo existed so early in the universe, it suggested that the processes of galaxy formation and evolution might have been much faster and more chaotic than we had previously imagined. Once again, the observations from the JWST were forcing us to rethink the way we viewed the cosmos. In light of these findings, many scientists are now exploring new theories that could help explain the rapid formation and evolution of galaxies and galaxy clusters in the early universe. Some believe that the universe may have undergone periods of intense, localized star formation, as suggested by the Starburst model, while others are looking into the possibility that our current understanding of gravity and cosmic forces is incomplete. Could there be other forces at play in the universe, forces that we have yet to discover or understand fully? As we continue to explore the universe with tools like the James Webb Space Telescope, it is becoming increasingly clear that our understanding of the cosmos is far from complete. The discoveries made by the JWST are just the beginning of a new era in cosmology, one in which the very foundations of our knowledge are being questioned and revised. Whether the universe created itself, as some have suggested, or whether new forces and dimensions are waiting to be discovered, only time will tell. What is certain is that the mysteries of the universe are far from solved, and the quest for knowledge will continue to push the boundaries of science and understanding. The questions raised by these recent discoveries are only the beginning, and the answers may forever change the way we view the cosmos and our place within it.